Okay, part C. So we have a third friend, Chris, also wants to reach the $20,000 target. He puts his money in a safe where he does not earn any interest. Bad idea, guys. If you want to save money, don't put your money in a safe. Anyway, his system is to add more money to this safe each year. Each year, he will add half the amount added in the previous year. Show that Chris will never reach the target if his initial deposit is $9,000. Okay, so he's going to add half of it each time, right? So watch this. This seems a bit strange. He's going to keep adding money every year, but he'll never reach his target. And that means never, ever. Even if he lives until $1 million, he'll never reach his target. Now, for me, straight away, I see what topic this is. I know where they're going, but let's get there. He's going to add 9,000 to his safe. He starts with 9,000. And then he adds half of that. So the next year he's going to half that. He's going to add 4,500. Then he's going to half that. And he's going to add 2,250. Is that right? Yes. Then he's going to half this, which is 1,125. Sorry, 25. Then he's going to add half of this, and he's going to keep adding it forever. What is this, guys? Yes, it is a sum to infinity. It is a sum to infinity, but sum to infinity of a geometric sequence. So the geometric sequence has U1, first term is 9,000. The common ratio, what are we doing to get to the next term? We're multiplying by a half. We're halving it. So R is equal to a half. The sum to infinity is U1 over 1 minus R. This is straight from the formula booklet. U1 is 9,000. 1 minus R is 1 minus a half. 1 minus a half. 9,000 over 1 minus a half is 18,000. So show that he'll never reach his target. You have to then say, guys, you're nearly finished, but you're not there yet. So the max he can reach is 18,000, which is less than 20,000. So if he was somehow hypothetically able to add half of this forever and ever and ever and ever, he won't get more than 18,000. In fact, really, he won't even get to 18,000, but that's the limit. That's the sum to infinity. Okay. Part II. Find the amount Chris needs to deposit initially in order to reach the target after 5 years. Give your answer to the nearest dollar. So, okay, so this has become, guys, this has simply become a geometric sequence question and a sum of geometric sequence. So the sum for geometric sequence is U1 1 minus R to the power of n over 1 minus R. In our situation here, we have first term 9,000. Our common ratio is a half. Our n is 5. This is 5 years. Sorry, no, I've made a mistake here. Our U1 is not, I was thinking, what are we actually going to have to find? Our U1 is not 9,000, because the question is, find the amount Chris needs to deposit initially. So this is actually what we're trying to find. We're trying to find U1. And he's going to reach his target. So S of n, the sum is actually going to be 20,000. So I'm going to sub in here 20,000. 20,000 equals U1, which I don't know, 1 minus R to the power of n, which is a half to the power of 5, close brackets, all over 1 minus a half. Now we should be able to just use nsolve to find U1. I can't see why this wouldn't work, because we're not dealing with the variable in the exponent or as the base of the exponent or anything like that. So hopefully this works. Menu, algebra, numerical solve, 20,000 equals, call it whatever you want, guys. Let's go with u. I'll do this though. U times 1 minus, I'll do 0.5 if you're okay with that, guys, instead of a half. 0.5 to the power of 5 all over, well, it's just 1 minus 0.5, which is 0.5. I'll do 1 minus 0.5. 1 minus 0.5, do comma u. So find me u, Mr. Calculator. 103. Hang on, I've definitely done something wrong here. What have I done incorrectly? No, sorry, that's fine. It's 10,320. I thought it was 100,000. So 10,322. 10,320. 10,322.6. But the question says, guys, the question says nearest dollar. So I'm going to say, therefore, min initial deposit is $10,323. Okay, that's question 7.